Numbers, decimals, and fractions, all simple but yet fundamental concepts. Today, we are going to learn what integers, decimals, and fractions are, and how to order them. An integer is a whole number with no fractions or decimals. It can be positive, negative, or zero. For example, a positive integer is any whole number from 1 to infinity, and a negative number is any whole number from -1 to negative infinity. 0 is also an integer, as it is a whole number with no fraction or decimal parts. Fractions and decimals are different ways of showing parts of a whole. Fraction is written as a numerator over a denominator. For example, 3/4 represents 3 parts out of 4 total parts. The numerator, the top number, shows the number of parts of the fraction, and the denominator, the bottom number, shows the total number of parts of the fraction. Decimals. Another way of showing parts of a whole uses a decimal point to separate the whole number part from the fraction part, instead of writing the numbers one on top of the other, like fractions. For example, the decimal 0.75 represents 7/10 and 5/100. Every digit after the decimal point represents fractions with denominators in increasing powers of 10. Now, you have learnt what integers, fractions, and decimals are, but the question is, how do we order them? Whole numbers are ordered using place value, which means we look at the digits from left to right, starting with the biggest place value first. But before we get onto that, we must look at two key terms, which are always specified during questions. Ascending order means we start from the smallest value to the largest value, and descending order is the opposite, from the largest value to the smallest value. As said previously, whole numbers are ordered using place value, and there are two steps to order them. First, we compare the number of digits of a number. The greater the number of digits of a number, the greater the number. For example, 10,000 is greater than 1,000 as it has more digits, 5 compared to 4. If the number of digits of a number are the same, we then move on to step 2. Starting from the leftmost digit, we compare the digits of the numbers of the same place value. If the digits are the same, we move on to the next digit to the right and compare those digits again. But if the digits are different, the number with the larger digit is greater. For example, 700 is greater than 500 as the leftmost digit, 7, is greater than 5. Before we move on, we should also be able to familiarize ourselves with place values. Well, on the diagram, the decimal point separates the whole numbers from the fraction parts. The place values increase from left to right and stretch all the way to infinite place values. Now, an exam-style question on ordering whole numbers. Order the following numbers in ascending order: 24, 6,492, 598, 78, 75, from smallest to largest. First, you compare the number of digits. 6,492 has the greatest number of digits, 4, so it is the largest number, followed by 598, which has 3. However, 24, 78, and 75 all have 2 digits, so we compare them, starting from the leftmost digit, which in this case is the tens value. As seen here, 2 is the smallest digit in the tens place, so it is the smallest number, but 78 and 75 both have the same number in the tens place, 7, so we move on to the next place value to the right, the unit. Now, by comparing the units place, we can see that 78 is greater than 75, as 8 is greater than 5 in the units place. Therefore, the final order is 24, 75, 78, 598, and 6,492, where 24 is the smallest and 6,492 is the largest. If the question asks for the descending order, the order of the numbers will be reversed, from largest to smallest. We also order decimals using place value. Firstly, we line up the decimal points of the numbers vertically to get each digit in the correct column. Then, like ordering numbers, we compare the digits in the place value columns, starting from the leftmost digit. If the number has a different number of digits, replace any gaps with a 0 when we line the numbers up to make it easier for us to compare. If you want a recap on fractions, decimals, and percentages, you can check the video here. Here's an example on ordering decimals. We have the following numbers: 1.65, 0.5, 0.75, 0.755, and 20, and are told to order them in ascending order, from smallest to largest. Firstly, we line up the decimal points in a column, making sure the place values line up with each other. Replace any gaps with a 0 to make it easier to compare, as they are all equivalent values. Next, like ordering numbers, we compare the digits, starting from the tens place, the leftmost digit. As 2 is the only digit in the tens place, 20 is the largest number. We then shift to the next leftmost digit, the units. As 1 is greater than 0, 1.65 is the second largest. Moving along again to the next column, the tenths. Out of the remaining numbers, 5 is the smallest value in the tenths place, so 0.5 is the smallest number. But as 0.75 and 0.755 both have 7 in the tenths column, we have to shift again to the hundredths column. A bit long, but with some practice, you won't even need to line them up in the future. You just have to eyeball it. We can see here that even in the hundredths column, the values are still the same, 5. So we move on to the final value, the thousandths, where we can see the digits are finally different. 5 is greater than 0, so we know that 0.755 is greater than 0.75. Therefore, the final order is 0.5, 0.75, 0.755, 1.65, and 20. We finally move on to ordering fractions, where there are two methods to order them, using common denominators or converting them into decimals. With the first method, we can compare fractions by using equivalent fractions with the common denominator before comparing the numerators. For example, this is one of the easier examples the examiners could give where the denominators are the same, so we can directly compare the fractions by looking at the numerator, where the greater the numerator, the greater the fraction. In this case, 5 is greater than 3, and 3 is greater than 1, so the order is 1/8, 3/8, and 5/8. With harder examples, we have to do a bit more work. For instance, this is a more likely question the examiners could give in the GCSEs. As the fractions have different denominators, you have to convert them into equivalent fractions with the common denominator using LCM. To find out how to calculate LCM, you can watch this video here. In this case, as the LCM of 8, 4, and 16 is 16, you can convert 3/8 and 1/4 into equivalent fractions, 6/16 and 4/16 respectively. Now, you can compare the numerators directly. 6 is greater than 4, and 4 is greater than 3, so the order is 3/16, 1/4, and 3/8. The second method to order fractions is to convert the decimals before comparing them. Using the same example, we convert 3/8, 1/4, and 3/16 into decimals before comparing them, using the place value method outlined before. 0.375 is the greatest number, and 0.1875 is the smallest number, so we return with the same order, 3/16, 1/4, and 3/8. We are required to know the following symbols for GCSE: equal to, not equal to, greater than or equal to, less than, and less than or equal to. These symbols are fundamental not only in ordering numbers and comparing which numbers are larger or smaller, but also in later mathematical functions, such as finding inequalities, which we will come to later in the year.